Hello, the name of the project is Geographic Information Systems Geospatial. My name is Anaí de los Reyes.
My name is Jimena Soto.
My name is Erin Ledesma.
And my name is Dara Alvarez.
And we're team number 7 from Irma Rangel Young Women's Leadership School. Today we'll be talking about our project, which is based off of geographic information systems, and they're used to capture geographic features displayed in different images that can be taken in different angles that are then analyzed to make a 3D model digitally. The purpose of our project is to demonstrate how drones and geospatial software can be used to preserve the historical value of a building. In this case, we used a building right next to our own school. It's called the Women's Museum, and it's in Fair Park, Texas. A drone along with the software was used to successfully capture images to create a 3D model of the building in low, medium, and high resolutions. The structures from motion were also a very crucial part of our experiment because it was basically the usage of overlaying images with the addition of depth and perspectives to create the 3D representation of this model. And it was used with a drone and the software.
So for our variables, we had our independent variable be the refinement of the three-dimensional images that were captured in different angles. And for our dependent variable, we had the final images that were adjusted in the 3 different resolutions, which were low, medium, and high. And so for our desired outcome, we had the 3 different resolutions. So for the low resolution, the image that was captured was not visible at all. So we had the different coordinates, and it was very pixelated. So it took a lot of editing to mesh the image together. And then for the medium resolution, the image was still not as visible, and we were still able to see a lot of those pixels and the coordinates. And then for the last one, the highest resolution, it took more time to develop, but we were able to fully see the building, the Women's Museum, and the quality was better than the rest of the other resolutions. And so below, we are able to see the image that we came with for the highest resolution, and we're able to see the full building at an angle. And so we were able to do this through what is known as computational photography, which is used a lot in GPS systems for navigational purposes and in the gaming industry. And the way this is done is that we had a pre-programmed drone take different images around the Women's Museum. And so it stopped at different timings to collect the different coordinates of the building and take the different images in different angles and depths in order to create a final 3D model. And so the drone was basically placed in different positions, and so we had several circuits going around. One of the first ones was in a circle, and then we had it where it was just making lines across and forth. And so there's 2 different methods that this can be done other than GIS systems, and those 2 methods are known as the Bears measure, where the coordinates are calculated, but it's done through a camera lens. And so this process takes much longer and it's more expensive. And the second one is the dense measure, where it's also calculating the different angles. But again, it takes much more time to do. And so through GIS systems, we had the flexibility to capture these images and work with this software to manipulate the images to look how we wanted them to look in the different angles that we collected them in.
So the materials needed for this experiment was a drone with integrated cameras and a computer with GIS software. So the first image depicted represents the sparse cloud at the lowest resolution, where the geospatial imagery consists of millions of coordinates pinpointed from the images from all angles to create a 3D model. The second image depicted shows our problem areas, where we encountered a problem with the angle of imagery and learned how important angles play to capture the entire building. The last image where all images were meshed together to display the 3D model in the highest resolution. It was our attempt to correct the holes, but due to the trees and angles of images, this is the best we could achieve in refinement.
So after conducting our experiment and after various trials, we can conclude that our hypothesis was correct on how the images would turn out. The low resolution was not clear enough and it was just pixelated, while the high resolution was the best outcome and the museum was completely recognizable. We can use this geospatial imagery for the future to preserve value of historical buildings in a digital way. And we also believe that for future experiments, a more spatial setting would become a better outcome, since there is more space to conduct the geospatial points. So thank you for viewing our presentation, and we hope that you enjoyed it.